Hi, my name is Harlimatun. Okay, the objective of this project experiment is to determine the thermodynamic function based on the electromotive force measurement. Introduction. Determining the thermodynamic function delta H, delta S, and delta G from EMF measurement of a reversible cell is generally more accurate than using calorimetric measurement, provided the cell is complete and easy to control. The EMF of a reversible cell represent the maximum work produced by the cell chemical reaction and reflect the changes in Gibbs free energy resulting from this reaction. The changes in Gibbs free energy and the cell potential is shown by an equation maximum electrical work equal to electrical charge transfer multiplied by Ecell. The value of delta G can be obtained directly from the cell EMF measurement. The other thermodynamic function, delta H and delta S, can be determined using the relationship provided by the Gibbs-Helmholtz equation. The equation involved is delta G equal to delta H minus T delta S. From the equation, it is obvious that at constant temperature and pressure, delta G have linear relationship with temperature K.
So the apparatus we use in this experiment is boiling tube, thermometer, rubber cork, salt bridge, beaker and water bath. And the chemical that we use is zinc electrode, lead electrode, copper electrode, 1 molar copper nitrate solution, 1 molar zinc nitrate solution and 1 molar lead nitrate solution. So based on the value that we get, value of Gibbs free energy, which is delta G that we got, we plot the graph Gibbs free energy against the absolute temperature for cell system zinc and lead. So from the equation of Gibbs free energy, we can compare it with y equals to mx plus c. Entropy, which is delta S, is equals to gradient, and we got positive 680, and delta H also we got positive, and we can conclude that this is endothermic reaction. Okay, for the second experiment, this is value that we got and the graph for Gibbs free energy against the absolute temperature for cell system copper with lead. For a second experiment, entropy delta S and enthalpy delta H that we got is negative, and it can conclude that this reaction is exothermic.
For the discussion part, for the system, zinc and Coulomb, we already identified that the delta H is 1.71 times 10 to the power of 5 joule per mole, and then since the delta H is greater than 0, hence this reaction is endothermic reaction. For the entropy change, for this system is 680 joule per mole per Kelvin. So, since the entropy is greater than 0, this reaction is preferably more ordered, and then the Gibbs free for this reaction is negative 3.17 times 10 to the power of 4 joule per mole, and then since the delta G is less than 0, hence the reaction is occurs spontaneously. For the system of copper and Coulomb, the delta H is negative 1.25 times 10 to the power of 5 joule per mole, and then this reaction is exothermic reaction. For the entropy changes, it is negative 76 joule per mole per Kelvin, and then the system is preferably less ordered, and then the Gibbs free for this reaction is negative 1.02 times 10 to the power of 5 joule per mole, and then it is non-spontaneous reaction. The precaution step that should be taken during this experiment is vary the temperature such as in range to 30 to 70 degrees Celsius, and then remove the oxide layer on the metals using sandpaper, and then use stirrer for even heating process for both electrolytes, and use buffer solution to prevent significant fluctuation of entropy. For the conclusion, we can conclude that the thermodynamic function can be determined by using electromotive force measurement (EMF). For system zinc and plumbum, the delta H is equal to 1.71 times 10 to the power of 5 joule per mole. Meanwhile, for the entropy changes is 680 joule per moles per Kelvin, and the Gibbs free energy is negative 3.17 times 10 to the power of 4 joule per mole. Meanwhile, for the system between copper and plumbum, the delta H is equal to negative 1.25 times 10 to the power of 5 joule per mole, and then the entropy changes is negative 76 joule per mole per Kelvin. And last but not least is the Gibbs free energy is negative 1.02 times 10 to the power of 5 joule per mole. Thank you.